So that being said, we are doing surface area first, and then we'll move into volume. Well, what is surface area? Who has an idea? What do you think surface area is?
The area around the surface.
The area around a surface. All right. Yes, that's right. That's good. So the way we are going to approach surface area is we're going to find, rather than memorize a bunch of formulas, we're going to basically do a bunch of net drawings. So let's just review. Well, what is, we did these at the beginning of the year, net drawing. So if I wanted to do a net drawing, say for this prism right here. Okay, so here's my triangular prism.
You unfold it.
I'm going to unfold it. That's essentially what a net drawing is. I unfold this and I think about, well, what shapes do I have here? Well, I have 2 triangles and 3 rectangles. Okay? But I might want to take note of the dimensions here. So if I said that this is 5 and this is maybe 6, maybe this is 10 right here, then I might want to note these dimensions on this paper. I want to take note of where all those are. So I find the area of each one of these shapes and add them up. That's the whole idea of surface area. So if I had a box, okay, so here's my box. And I unfolded that box. So I might unfold it like, I might have these 2 tops, so I'm going to think of, this is my center. So this is this center one, so this is 6 and this is 3. And then I might unfold the 2 top and bottom right there. So there's my top. So, well, what are the dimensions of that top and bottom? If I'm looking at this and I'm unfolding it, those are right there. What are those dimensions?
It's a 3 by 4.
It's a 3 by 4. So 3, 4, like that. 3, 4. All right, and then I have along the 6, I'm going to have another thing. Now, presumably, these sides would fold up and meet, right? So this side would have to be a 4. And then I'll have another one, and another one, and another one. Okay? All with a side length of 4 there. Okay? So that's how you do the net drawing. But the real question is, how are we going to get the surface area? Okay, this is the area on the outside. We find the area of each one of these things and add them up. Oops. This is all Algebra 2 stuff. Get rid of it. Okay, so let's go ahead and find the surface area. So we're going to find the surface area for each of these. And then we are going to have to do some slanty shapes. So we'll do a triangular prism first, because I find, for whatever reason, everyone messes up the triangular prism. I don't know why you mess up a triangular prism, but you do. Now, trigonometry is fair game on all of these, but I'm not going to, just for the point of just getting down what we are supposed to be doing, I'm not going to throw that in just yet. So let's say the height of this triangle is 5. Let's say the base of this triangle is 10. And let's see here. Let's say this slanted thing, let's say that's 6. And let's say this slanted thing is 7. And let's say this length is 12. So you have to have a lot of information in order to do surface area. Actually, surface area, you need a lot more information than to do volume. Surface area, I think, is a lot harder than volume. So surface area is square inches. And what I would do is I would identify each of my faces. So every single shape is going to be different. Okay? Well, I have a front and back, right?
Correct.
And those are triangles. So I might write down front and back because those are the same, right? The front and the back are what shape?
Triangle.
And we should know what formula do we use.
Base divided by 2.
Okay? And what's the base of my triangle?
10.
10. And what's the height of my triangle?
5.
Divided by 2. And I get
25.
25. But I have 2 of them. Now, some of you might be thinking, then why did I divide by 2? Because I'm going to end up undoing it, right? I'm going to go back to the 50. And I have 50 units squared. Now, so this is part of my answer here. I'm going to have to use that. I would argue that you still need to do this, even though you're going to undo it later, because otherwise you might mistakenly think all areas of a triangle are base times height without the divide 2, and then you end up making errors on things that you shouldn't. So I would write it anyway. But you know what you're going to get in the end. Those twos undo each other. Any questions on how I got the area of the front and back?
No.
Daniel says no. How about anyone else?
No.
Okay, so now I have this rectangle. And you might think, well, is that rectangle identical to this one right here in the slanted side right there? And no, it's not identical because this one has a length 6 and 12, but this one has 7 and 12. Okay, so I'm going to do left side.
Okay.
And I'm going to have the right side. So the left side is a box, base times height. The right side is a box also, base times height. The base of the left-hand side, well, what's that length? Now you might think 5 because of the way I've written, but I meant that 5 to be the height of the triangle.
12.
It's 12. So the base is 12 and the height is 7. So I get 84 in the end there. And I only have one of those. So that's part of my answer. The right-hand side, I have a length of 12 and a height of 6. So 12 times 6. So I have 72 units squared. Now I'm going to add those all up. I'm missing one.
Yes.
I'm missing the bottom. And what shape is the bottom?
Rectangle.
It's a rectangle, so base times height again. So I'm going to have 10 times 12, and I'm going to get 120 units squared.
So add
Now,
those together.
surface area, I'm going to add those all up. So 50 plus 72 plus 84 plus 120 gives me
50 plus 72 plus 1.
okay, call it out.
326.
Yes.
326 units squared confirmed. Now, I don't want to spend a lot of time in your notes doing examples. I'd rather you trying these, making some mistakes because, and we'll get some manipulatives in here so that you can see. I think it's easier to see them like in front of you rather than trying to draw all these things. Let's do a box. A box should be the easiest. So let's do a box.
So right now, let's just kind of like practice.
No, we're learning something.
We're taking notes to learn how to do it. But we did this in pre-algebra class, right?
Yeah.
C.
So here's the box. We're going to find the surface area of this box.
It's a package from FedEx.
And we'll give some definite inches here. Definite units. So we have our box, and we want to know the surface area. So basically, what kind of questions I might ask? Well, I might be asking, well, how much paint do I need to cover this? You know, that might be what I'm asking. I'm not asking how much paint to fill this. That would be a different question. I'm painting it. So I'm asking to find the surface area. So on a box, I'm going to have, hopefully you see, are we not messing around up there in front? Okay, so here's our box. I'm going to have a front and back. Front, back. Do you see what I'm talking about?
Yeah.
Front, back. Okay, what shape is my front and back?
Square.
Rectangle.
Rectangle, base times height. And what are the dimensions of my rectangle?
10 and 3.
10 and 3. Any questions on why it's 10 and 3?
No.
So I get 30, but I have how many of them?
2.
2. So I actually have
60.
60 inches squared. Okay, got my front and back. Okay, now I'm going to have my left and right. I want you identifying these in your homework, that you know which one you're talking about so your work is organized. What shape do I have on the left and right?
Rectangles.
Rectangles again. So base times height. But what are my dimensions?
3 times 16.
Good. And I get 48, and I have how many of them? 2. So times 2, and I get
96.
96 inches squared. Good job. And then we have one more, top and bottom. And those are also boxes, but what are their dimensions?
They're different.
16 and 10.
16 and
10.
10. So that's 160. And I have 2 of them, right? So that is going to be 320. Now, what do I do with all of these? Add them up. So my surface area is going to be 60 plus 96 plus 320.
476.
And I heard 476. Verify?
That's right.
All right. Final answer. See, I've full boxed my final answer. See how we organize our work? All right. So let's do a tricky one. A cylinder. So a cylinder looks something like this. Okay, there's our cylinder.
It's the easiest shape to draw. I like to do it.
And let's say that's 6 feet. Let's say this is 12 feet. All right, in order to do a cylinder, let's take a look at our net drawing. So if I were to unfold this, hopefully you see I would have a circle at the top, a rectangle that is wrapped around the circle, and then a circle at bottom, right? So I need to find the areas of the circles and the rectangle. Now the areas of the circles are not going to be hard, but the tricky part is going to be finding the area of the rectangle. So if I've unfolded this, what length is this right here?
6.
No.
12.
12. It is not 6. In fact, none of the dimensions are actually a 6. Okay? The next question is going to be, what is this length here? Now, we need to think before you call out something. Remember, this is wrapped around the circle, and Victoria is very excited to say that it is...
The circumference of the circle.
This is the circumference of the circle. So this would be pi d. Well, what's my diameter? 6. So it is 6 pi. Not 12, it is 6 pi. Because my diameter is 6, so this circumference is pi d. You with me, Evan? Okay. So, I need the area of the box, and I need the area of the circles, but I have 2 of the circles. Let's get the area of the circles. What formula should I use?
Yeah.
Pi r squared. What is r?
3.
Are we writing this down?
Yes.
Okay, so r is 3, so I get 9 pi. Any questions on 9 pi? 9 pi feet squared.
Do you have to leave it
I
for
have a
the
question.
For now I am. What's your question?
I'm not asking.
Okay, now I have 2 of them, so times 2, and I get 18 pi feet squared. Okay, that's the top and bottom. Those are the circles. Now I need to get the area of the box. Area of the box is base times height.
12.
So I have 12 as my height, and my base is,
18 pi.
where'd you get
6
18 pi from? 6 pi?
Okay.
is my base.
Okay.
Okay, because look, it's a circle,
Yes.
and this is wrapped around the circle.
Mm-hmm.
So this length is the circumference of the circle. The circumference of the circle is pi d. D is 6, so 6 pi. Hence, this length is 6 pi. So 12 times 6 is,
72 pi.
so I get 72 pi, and I only have one of those. What do I do with these two parts? I add them, and I get 90 pi feet squared as my final answer. Okay, so for some of you, it might be helpful for a cylinder just to have a formula that will give you the surface area. In which case, you are going to have to memorize the following formula. The surface area of a cylinder is height times diameter times pi plus 2 pi r squared. That is the surface area of a cylinder. I like to just dissect it into pieces and figure it out that way, but if you are one of those who needs a formula, there is a formula. So once again, that it would be height times diameter times pi plus 2 pi r squared.
Isn't that a lot easier than what we just did? Just
It's
using the formula?
exactly the same thing as what we just did. Okay? It is exactly the same thing.
Okay.
This piece goes right here, and this piece goes right there,
And 6 is the diameter.
Yes.
because that's what I gave you in this example. Let's do another cylinder. Okay, let's say this right here, let's say that is 15 inches. Now pay attention to the information I'm giving you. Let's say this is 4 inches.
That's the radius.
This is a radius. You must pay attention to the information you are given so that you don't make bonobo mistakes. I'm going to do it by dissecting the shape. So I have a rectangle and I have a circle. To get the area of the circle, what do I do?
Pi r squared.
Pi r squared. What's r? 4. So 4 squared pi, 16 pi, but I have how many of them?
2.
Times 2, and I get 32 pi. Okay, that's part of my answer. Now, I have unraveled this rectangle. So this is the circumference of my circle, which is pi d. What's d?
8.
D is 8, so the circumference is 8 pi, so this length is 8 pi. Right here, this would be my height, this is 15. So the area of the box is base times height, which is 8 pi times 15. What do I get?
125.
120 pi. Now, since these are like terms, I can just add them. Surface area is 120 pi plus 32 pi, giving me 152 pi inches squared. Surface area.
I did the formula and I'm not good at
Okay, let's try the formula. Maybe I made a mistake when I wrote the formula.
No, I did the same thing.
Okay, the formula is height, right? Times diameter times pi plus 2 pi r squared, because I have two circles. So you should get exactly the same thing. Our height is 15. Our diameter is
8.
8 pi plus 2 times, now I'll put pi at the end, r squared. What's r squared?
16.
16. So this is 120 pi plus
32.
32 pi, which is 152 pi. It comes out identical.
Yeah, sorry, I did that.
Okay, so if I wanted an estimate, I will replace pi with 3.14 and get an estimate at the end. All right. basically it comes down to, all of them come down to that. I am going to talk about one more thing, unit conversions.
Oh boy.
And this is, oh, get your undies out of the bunch for the love of humanity. All right, so let's say I have 6 feet and I want to change that to inches.
50 inches.
Okay, there are 12 inches in 1 foot, right? Okay, so some of you jumped and you already know it is going to end up being 72 inches. Okay, which works great for simple calculations like that. I want to show you how to do it when you have a not so simple calculation. So we have 6 feet over 1. We always write what we start with, and we always multiply. And we always do what I'm about to do next. Whatever's here crisscrosses down to here, and whatever I want to change to is up here. It's factor label, works great in chemistry. Okay, so the number, my conversion, usually goes with a smaller unit. Inches are smaller than feet, so 12, 1. So 72 inches. Top times top, bottom times bottom.
Well, what if you get a decimal? I mean,
Oh,
a
well,
fraction.
you get a decimal, that's
Have a
fine.
fraction.
Okay, that's fine. It doesn't matter. Okay, in fact, the next one we are going to get just that. What if I wanted 4 inches and I wanted to change that? And this is a realistic thing to need to do. To actually have it in feet, because maybe I'm not able to measure in inches. Okay, so I'm going to change 4 inches to feet. I always start with what I'm given. 4 inches over 1 times. I always multiply. Whatever is here, you know, don't get unnecessarily crusty, goes down here. And feet goes up here. See, whatever unit, I have inches, see, it crisscrossed down. Not hard. Now, how many inches are in a foot?
12.
12. 12 goes with the smaller unit. Top times top, bottom times bottom, equals 1/3. If you're trying to tell me how to do it faster, I don't care about that. Okay, so we get 1/3 feet. What's your thing?
Can we leave them in fractions
Yes.
instead of,
Yes, that is fine.
1.3 repeated?
Yes, that's fine.
Oh.
Okay, so 1/3 foot. So you look at your foot stick and say 1/3 of that. That's fine.
Or what?
My foot
Whatever.
stick.
Okay, we are going on. We are going on because actually you should already know how to do what I just did. The question now is, how do I change from units to units squared? Okay, let's do feet as an example. 12 inches equals
1 foot.
1 foot. How many inches equals 1 foot squared? Well, what did I do to the right-hand side? I squared it. So what do I do to the left-hand side? I square it. 144 inches squared.
That's it.
That is it. So now, what if I need to convert inches squared to feet squared? And so, especially for honors, you're going to need to be doing something similar. Okay, so let's say I have 16 feet squared, and I want to know, well, how many inches squared is that? Now, hopefully you can see 16 times 144, right? But if not, you factor label. 16 feet squared over 1 times feet squared on bottom, inches squared on top. Inches are smaller than feet, so 144 on top. 16 times 144 gives me what?
$2,304.
2,000 what?
304.
304. Okay, good. All right, let's extend that idea. How to go from inches to feet cubed. And this applies to any unit. Same concept. Well, 12 inches equals 1 foot. I want to know feet cubed. So what do I do with the 12 inches?
Cube it.
Cube it. So 12 cubed is,
1,728.
Woo!
so there are 1,728 cubic inches in 1 cubic foot. So honors for your honors project, this one you'll be using a lot. Okay? That one is very important. Just because of the concept of the problem. It could have just as easily been centimeters cubed to meters cubed. Which actually, let's do that. How many centimeters are in a cubic meter? Well, how many centimeters are in a meter? So centimeters in a meter.
Isn't it? Or 10. 100, isn't it?
100 centimeters in 1 meter.
Metric.
So if I have a cubic meter, what do I do with that 100?
Cube it.
Wait.
1, 2, 3. 1 million.
Yes. 1 million cubic centimeters in a cubic meter. Alright, we're done. Put away your notes.